Hi everyone. Today I want to discuss an important topic in data visualization, and that's how to get rid of pie charts and replace them with something much better. But first, let's start with what are pie charts and why should you stay away from them. A pie chart is a circle or a ring, if you call it ring charts or donut charts, all basically the same names for things that are very similar. And that circle is split into segments according to the distribution of a categorical variable. You'll see an example in this video in a moment. The problem with a pie chart is that it's misleading. The segment size is determined by the angle, but our eyes are led to identify the volume as size. Also, if you want to compare one category as a function of another category, it's very hard to do that with pie charts. You would have to put pie charts one next to the other and kind of try to compare, or maybe use the numbers instead of visualization. And it's hard to compare. Another thing is that it can lead to errors, such as distributing more than 100% in a single chart. For example, in case you have a few variables with overlapping categories. Anyway, what I want to show you today is how to switch from a pie chart to a bar chart. And I'm going to suggest a few types of bar charts according to what you need. I'm going to use R and ggplot2 to generate the charts. We're also going to use some functions from dplyr and some auxiliary functions from other packages. But to reproduce this video, all you need is R with the tidyverse package installed and the Palmer Penguins package installed, which is the dataset I'm using. So let's go ahead and see everything. So first off, I want to show you what not to do. We'll be working with the Palmer Penguins dataset. So I've already opened it in Excel, even though we're not going to use that. We're going to open it from the Palmer Penguins package in R. But just to kind of show you, we have a few variables here that we're going to use. We have the species variable, which shows for every observation what type of penguin was it. So we have a few types like Adelie, Chinstrap, and Gentoo. We have an island variable showing where the observation was taken. And we have a few islands here like Torgelsen, Dream, and Bisco, I think, something like that, yeah. And we might also use sex and year. All of them are, you could say, categorical variables. We're not going to use the continuous variables that you see here, like bill length, bill depth, flipper length, and body mass. I have a different video covering these, so if you want to see kind of how to visualize them, you can switch to that other video showing other chart types. So I've already took the liberty of generating a forbidden pie chart, one would say, and that's here in the second sheet. We have a simple pivot table counting the penguin types, or how many penguins of type Adelie or type Chinstrap or type Gentoo we have. And I've generated a pie chart, which I'm now going to show you how to replace with a much better bar chart. And then we're also going to cross the different variables like species and island and show how to compare them with a bar chart and everything like that. So let's stop with Excel and switch to R. So here's my R, and what I'm doing first is loading the libraries that I need. As I said, I'm going to use the tidyverse library. I'm actually using only probably 2 or 3 packages within that library, like ggplot2 and dplyr, but I'm going to load everything anyway. And I'm also going to use the Palmer Penguins package for loading the dataset that I've shown you earlier. So the dataset is here under penguins. Right. So we see the dataset here, and the first goal is to generate a distribution of species. So all we have to do is take the penguins dataset and pipe it through into a ggplot command, where we map the aesthetics of the species into the x-axis and add a geometric called geom bar. And what we get here is a chart showing the same thing as we had before with the pie chart, only this time as a bar chart. The x-axis has the penguin types, and the count shows the number of observations within that. What I really like to do is to give me slightly more flexibility. So what I usually do is, instead of using the geom bar, I kind of count the penguins type that I want. So I'm making a table here, which is already a table that I had, like the pivot table that I had in Excel. And what I can also do is add the proportion of each type. We're going to use it in a while to improve our bar chart. So I'm going to add a proportion. It's the column, the variable n, divided by the total sum of n. So that would give me the proportion, as you can see here. So I have the previous table, and now I have a new column called proportion. So we can see that the Adelie penguins, which are 152 observations, are 44.2% of the entire penguin population we have in the sample. And now, again, I'm going to use ggplot. Instead of using the geom bar, I'm going to use the geom-col geometry. So I will be mapping the species to X as before, only this time I'll be mapping the y-axis as well, and I'm going to be mapping n for that, and adding geom-col instead of geom-bar. And now what you see here is exactly the same bar chart. You actually didn't even see it change because it's the same, but I do have slightly more flexibility. For example, it's very easy to add a label, and I'm going to map the label aesthetics and say, I'm using a package called glue here, and say, let's say I want the sample size, and in parentheses I want the proportion. So that would be something like that: round, prop. We have to duplicate that by 100 to get the proportions and add the percent sign. So what? Okay, we have an error here. Why do we have an error? Because, oh, I have a typo here in the label. It actually said ignoring unknown aesthetics label. That's the reason. Okay, so we see at Adelie, it's 152 observations. We also see the percent of them. It's 44% of the population. And yeah, we can try and style this chart a bit. So let's use a different theme BW, to clean it up a bit. So you see the background has changed from gray, and we can also remove the grid lines. So panel grid element blank, right? So that's gives us a bit of a cleaner kind of layout. And GG title, we want to call it the distribution of penguins in the Palmer penguins data set. And yeah, we can even give it color. I don't necessarily want to color them now, but you know what? Maybe to prove beneficial later on. So let's give them a color. Fill equals species, so that each penguin type is going to be colored. And yeah, there we have it. The distribution of penguins in the Palmer penguins data set. Another thing that I like to do is kind of just adjust a bit the text. Yeah, I don't want the text to be in the legend here that you see, so I'm just going to add here in the geom label, show legend equals false, so we don't get the small a here in the legend. We don't actually need it, right? And yeah, let's just the label, let's call it penguin species. So that would be on the X label, and on the white label we'd have number of observations, right? So that's our final first bar chart over here. And what we want to do next is add a bar chart comparing the distribution of penguins per each island. Yeah, so think about that. Like if you would have wanted to do that with pie charts, it would be almost impossible to yield a result which would be very clear to people because they would have to compare to pie charts, which is very hard. But as you will see in a moment, with bar charts, it's very simple. So we're going to start the same in the same manner that we did before. I'm going to add a comment here, a distribution of species per island. So again, the island is just another variable here, which shows you for each observation where it was measured. So we're going to take penguins here. And instead of counting the species, I'm going to count the species and island, right? So that gives us a table. Okay, penguins is not found because I had a typo in penguins. Yeah, okay, fix the typo. And now we have a table, right? So this table shows, for example, that Adelie was measured in all 3 islands, and that Chinstrap was measured only in Dream, and Gentoo was measured only in Bisco. So it's not going to be a very interesting chart, right? But you can start and get the hang of it. Maybe we'll do another one with the sex later on. So okay, and now that we have that, yeah, let's also count the percent. And in a moment, you will understand why. We'll count the percent of each penguin type in each island. So we're going to group by island. And then I want to do a mutate and add penguin type. Would be penguin type percent would be n divided by sum n. Right, so I don't want mutate, I actually want summarize, I think. Yeah, let's see what we get here. Summarize. We get an error or a warning message. Oh yeah, so in Turgeson we only had one type, but we lost the. Why did we lose the penguin type? Yeah, I probably wanted to mutate instead. Yeah, right. Let's see. Yeah, okay, that's what I wanted. I could probably reverse the order and using group by before the count and getting the same result. So never mind. So what we see here, for example, is that for each island, the percentages are summed into 1. So for example, in Turgerson, we only have one type of penguin, which is Adelie, and that's why we see here 1. That represents 100%. And if we take Bisco, for example, we have 44 penguins of type Adelie, which represent 26% of the sample. And we also have the Gentoo detected in the same island, and much more of them, like 124 in that island, and they represent 73.8% of the sample in that island. So that's what we see here, penguin type sample percent. So the next up, what we want to do is start working with ggplot. Okay, we're going to map the island into the x-axis. We're going to map the penguin type percent into the y-axis. And we're going to add a geom call as we had before. The only thing that I left out here is that I also want to color them, colored columns. So I'm going to use the fill argument here and put the species in the fill. So once I do that, we get this chart over here. You see that the colors are consistent with the previous one. R uses ggplot2 uses the lexicographic order, like the alphabetical order, to color them. So we get the same colors as we did before, with Adelie being red and Chinstrap being green and Gentoo being blue. And yeah, we can add the same things that we add before to make them a bit clearer. So what we can do here is add the label. Now, instead of using the prop here in the label, we want to add penguin type percent. And the end is going to be the same. It's okay. And we use the cleaner theme, the theme BW without panel grid. Everything is the same. Only I'm going to change the title, the distribution of penguins in the Palmer Penguins dataset. And let's add subtitle separated by the measurement island. Okay. Instead of using on the y-axis the number of observations, I'm gonna, the axis also has to change. So instead of penguin species, I'm going to write island. And instead of number of observations, I would say a penguin distribution. Okay, and there you have it. Okay, one thing that you can immediately see here is that we have a mix-up with the labels. So we have to fix that, and that would be easily fixed. R uses something called position, I think. So we need to have it, we need to align the geom label with the right position. The position here is called stack or fill. It's the same here. Stack is basically stacking the numbers one over the other, and fill is fitting up to 100%. Since we're using the penguin type percent as the y-axis, it would be the same in this case. But I'm going to use position fill, and I'm going to show you where it's not the same in a moment. Okay, so now you have it. The labels are okay. We see the island Turgestan has only Adelie, and that the Dream and Bisco are split between two types of penguins and different penguins. So you can get a sense of where penguins are. You can see that the Adelie penguins are available or exist in all of the islands, and Chinstrap is unique to the Dream Island. Bisco Gentoo is unique to the Bisco Island, and so forth and so on. Let's fix one more thing. You can see that the y-axis is numbers between 0 and 1 probabilities, and instead of probabilities, let's make it a slightly more beautiful using the scale y continuous function, with the labels argument being scales percent. So I'm using another function from a different package here called scales, and there you have it, the distribution and a bar chart of the various penguin types in each island. And this is something you could not have achieved in a pie chart, getting a clear or understandable result. You can try, but this a bar chart is much better. So I wanna hold on just one more point that I was talking and discussing about, the position fill. Sometimes instead of distribution, like instead of percentages, we would like to have the actual numbers, right? So that might say something about the number of penguins measured and not just the distribution. Maybe we want to put an emphasis on the number of penguins instead of the distribution, instead of percentages. So to do that, all we need to do, it's going to be very simple, very similar to what we've already done. We don't actually need the group by and mutate. I'm going to remove them. And we do need the ggplot with island mapped into the X. Instead of using penguin type percent, I'm using N, the numbers, the actual numbers of penguins, with the same species map to fill for the colors, with the same geom call. The label would be just N, right? The sample size. We don't have percentages now. We don't need them. So yeah, let's just, I don't need the clue. I just put an N here. We could have added percentages just for the fun of it, but let's make it simple. And instead of using position fill, I'm using position stack, right? So I need to put that in two places just for being accurate. Let's put it in the geom call and also in the geom label. And actually the titles would be the same except for the ylab. It's not the penguin distribution. I would say it's the number of penguins. Number of penguins and number of sample penguins if we want to be accurate. And we don't need the percent here, right? So what we get here is a similar bar chart, only this time The bar charts are not scaled to 100%. And this chart tells a completely different story, right? Because it shows you that in the Turgerson, you had a smaller sample, right? Just 50 penguins, 52 penguins. And when you compare it to the Bisco Island, for example, you see a much larger sample of 168, I think. Yeah, penguins. Most of them are Gentoo, some of them are Adelie. And you can also compare the portion of Adelie in the different sampled islands. So it kind of gives you a slightly different outlook on the data. So it's a different story that this chart tells you in comparison of the other chart. So you can generalize this. And when I showed you the data set itself earlier in this video, also I told you that we might want to use something other than the island and penguin type. So you can do the same with, for example, a penguin type and sex, right? So if you want to show, for example, the distribution of penguin sex, gender, all you have to do is replace the island with sex. So I'm going to replace the island with sex, and we would get or maybe, you know what? Let's do it the other way around. Let's replace it here, but I want the species to be in the to be a constant, and I want to see the distribution of sex within each species. So we would imagine that it's more or less 50%. So let's make sure. Let's see if that's right. So all I need to do is replace the island with species here, and the field I want it to be sex. And the thing about ggplot is it's going to change the colors from three categories, like the color of species that was three categories and had red, green, and blue. It's going to change it to just blue and red, but different shades of blue and red, so it would be more discernible. Okay, so yeah, and this one stays the same. Everything here is the same. The title, the distribution of penguins, distribution of penguin gender in the Palm penguin dataset, separated by the penguin species type. Yeah, X is going to be species, Y is going to be sex distribution. I'm interchangeably using sex and gender. I don't actually know why. Yeah. Okay, let's see what we got here. And yeah, oh, that's interesting. I didn't expect that. You see, the gray areas here are actually observations where the sex is unknown. Maybe it's a bit harder to determine the sex of Gentoo and Adelie because there are missing values only in them. Maybe it's just a fluke. So we can see that the sample is split in the middle for each penguin type, right? Except for maybe in Gentoo, where we have a slightly larger number for males, but it's more or less they probably aimed for it. They didn't want to bias when they sampled the data, so it's probably maybe the end for measuring these types of sex within each species, right? So there you have it. We took a pie chart, we've turned it into a bar chart. That was the first one that we had here. We gave it some colors. We cleaned up the chart a bit. We added labels, which are very easy to understand and see what penguin type or how many of penguin types we have. Very easy to compare. We then generalized it a bit and saw two variations of bar charts illustrating the distributions of penguin species within each island. And yeah, then we shown how easy it is to generalize it if we want sex, for example, of each species type. So there you have it. I hope you've enjoyed this video. Drop me a line in the comments below and let me know what other topics you think I should cover about R and data science and visualizations. Subscribe to my channel to get notified where new videos are available. And see you next time.